Why do we do open hardware? And a little bit about Rittal in terms of our open rack infrastructure, along with some of our smart Rittal solutions. So I want to start really with some slides that were presented in the US back in March of this year by the chair of Open Compute, and it was really showing the growth of the open compute community in the coming 4 to 5 years. Now, at the moment, within that community, the main board members are Facebook, Microsoft, Intel, Goldman Sachs, and Microsoft. That aside, without those guys in it, there's around about 1.2 billion US dollars of spend last year on open compute compliant products. They expect, which represents around 0.9% of the whole IT infrastructure spend. I reckon by 2021, this is going to grow some in the region of 5-fold. So around about $6 billion will be spent on open compute hardware somewhere around 2021. And the market share of open compute will go to around about 3 to 4% market share. So I guess, where is it actually coming from? In which area is it all sliced up, ready for the growth? Well, actually they're all growing. Whether it's the enterprise, or service providers, or hyperscalers, or maybe cloud service provider tier 2 level, and telcos, they're all growing. I know the graph may look as though it isn't growing, but this is just a percentage. As you can see, that the biggest growth is actually the telcos, so the green ones are growing from around about last year 30 million US dollars, significantly by 2021 to around 2 billion US dollars. And the prime reason for that is with OCP in particular, as 48-volt architecture comes on board, and I'll explain a little more of that going forward. The telcos will certainly be interested in this with their 5G rollouts through 2020 and beyond. The enterprise is growing to about 1 billion from 0.15 billion, and hyperscalers, people like Facebook, who started this whole community back in 2012 along with others, or 2011, sorry, with the others, will continue to grow. So I guess a little bit of background on what the Open Compute project is. So first of all, it's an industry non-profit focused market established on open sourced hardware. In other words, hardware that's shared by the community or by developers into the community to allow people to either use it, manufacture their own based on a set of specifications. It was founded in 2011 by Facebook, or actually three members, Facebook, Rackspace and Intel. And now there's some 200 members and it's still growing. Rittal being a part of that community as of a couple of years ago. 2 extra board members came on board in the last few years, and those being Microsoft and Goldman Sachs. And Microsoft are heavy contributors within this with their Olympus project for the last 3 or 4 years, and continue to be. A part of the whole community is about IP contributions. So each member of the community, as a requirement, needs to be contributing. That's really the air that the community breathes, are the contributions it makes to the community. And these are technology, hardware contributions. And up till now, we've had 140 contributions have been accepted from 22 different companies, representing over 170 products. So over the past 4 or 5 years in particular, the whole infrastructure of open compute is growing. And the more contributions we get, it allows more developers out there, hardware developers, to access the market, and solution providers to access that market. And it is a technology-driven focused board, defining scope and community-defined technologies. So how do they go about recognizing contributions, bringing it to market? And there's lots of different ways and lots of different workshops. Specifications being the first one. So in the early days of a new topic, and typically in the Open Compute Forum, there are 8 main groups, from Rack and Power Group, which we're heavily involved in, to high performance computing, to networking, to servers, and so on, at the data center level. Each of these is chaired by somebody, and people register their interest in that. And we basically meet every 3 months, face-to-face sometimes, or monthly on calls, and we write specifications. It starts as a general requirement, in maybe 2012. I talk from experience on rack and power, and we spent probably 1 to 2 years writing the specification in great detail, right the way into how we manufacture a product, the tolerance of the product, the interchangeability of it with all the servers, etc. There's a lot of tested configurations out there, so once we write specifications, we then have to develop the product. We have to develop prototypes, and we have to do the interchangeability and all the testing of the products to make sure that what we have talked about, what we have specified, what we have developed works with all the different working groups, whether it's at a data center level, or it's at a rack level, or it's at a server level, right the way down to chip level. So making sure that everything is completely interchangeable. There's a lot of white papers in the community, design files, product recognition, and there's a lot of case studies. I've already mentioned the workshop summits. Those happen every month to 3 months. But it's well worth it, and I'll give some information at the end maybe, is to look at the opencompute.org website. There's wiki pages within it, and you can see all of the old summits, all the old specifications, all the old links, right the way through to webinars, and it's all freely available for everyone to read. So a little bit about why open hardware. Well, I think most people are very familiar with open software. It's a fairly, with OpenStack, etc., it's a fairly standard way of doing software development. But with open hardware, a little bit different. You know, hardware manufacturers traditionally are quite reluctant to share hardware for obvious reasons, intellectual property, etc., and sharing of hardware. And the whole ethos of Open Compute in 2011, 2012 was to actually bring in a large pool of developers. So the idea being that you can solve problems quicker with a lot of good minds around a problem. And to that end, when Facebook set this up with Intel and Rackspace, they invited a lot of key developers in with it. And part of the workshops is actually sat down developing real strong hardware with sometimes competitors, sometimes suppliers and solution providers. So the aim being to develop a hardware solution much quicker, much faster, and hopefully becomes a much more efficient and manufacturable solution worldwide. We develop things like, so the other reasons for it, of course, is customization and efficiency at a rack scale. Of course, if we can do it as a community and as a team, it allows us to have scalability of the product, it allows us to manufacture to levels of standardization around it. So the other reason for open hardware is actually, as I mentioned earlier, is to solve problems quicker. There's a lot of challenges coming up in the next few years, and probably 5 years ago we were saying something similar, but with a different set of problems. At that time, the challenges were, I guess for Facebook, was how to scale quicker and how to grow the data center market, and generally at a hyperscale level, it solved the problems of power, cooling, rollouts and solutions. Over the next few years, we know that data volumes are increasing exponentially. You know, efficient and fast data processing will, in future, be more decisive in business successes. Whether it's edge solutions for people that are communicating incredibly close to the point of contact, or actually artificial intelligence, virtual reality is growing in the next few years a huge amount. And that's going to mean certain communication architectures at a chip level and at a motherboard level that need to be working incredibly fast. So data processing needs to be very, very quick. Obviously that will generate heat and power problems and everything else that goes with it. The idea of the open compute platform is, number one, to reduce the investment and the operating costs. So CapEx costs and OpEx costs are one of the key targets of this, otherwise why would you do it? Now in the early days, one of the reasons to do it was to break the cycle with the traditional OEMs. So in the early days, the server providers, maybe 10 years ago, were traditionally the HPs of the world, the Dells, the IBMs and so on. And people like Facebook and other hyperscale type companies would not quite want what was being offered at that time. So they chose to go out and develop and I guess they had scale to do it as well, develop a solution that absolutely suited them with not everything in it that they needed. So a very bespoke solution around it, and went to ODMs to manufacture. The reduction in energy consumption was definitely a key aspect of it. So having 12 volt DC, if you look on our stand behind you, the Rittal stand, you'll see 2 or 3 open compute solutions, different configurations. So reduction in energy consumption was definitely a key aspect. And I know the Primeville data center for Facebook, which is publicly available, runs at a PUE of 1.06, I believe, at the moment. And again, to the next point, environmental impact of data centers by way of innovation. Having full standardized architecture so it can roll in, deploy much quicker, use less energy, and be much more efficient. And the main reason was sharing ideas and know-how. Going back to the point I made earlier, we share ideas, we share our know-how, we share our experiences, and we develop products quicker that way than we would on our own in isolation and in silos. So going to Rittal and what we actually do in the open compute community. Primarily we do rack and rack infrastructure and power and bus bars. But from a solution point of view, going back a step, the open rack is the first rack standard that's designed for data centers. If we go back, say, 50, 60 years was when the 19-inch enclosure was brought out for the railway industry, actually, and nothing's really changed on that. And a lot of things at data center level, whether it's servers or data centers, have been designed around or with the 19-inch in mind. With open compute, what's changed is they completely changed it from a data center down. And at a rack level, some of the key features, again, if you look on the stand, you'll see them. It's changed from a 19-inch to a 21-inch. And what that allows you to do is a few things, actually. It allows you, number one, to have 2 inches or more space. That allows 5 3.5-inch hard drives to fit across the width, whereas normally it'll be 4. And again, we've got some trays over there. You can see the 5 flat going side to side. They changed things like U-spacing. So the U-spacing went from what is traditional at 44.45 millimeters, which is 1 3/4 inches, to 48 millimeters. It doesn't sound a lot, but when you're putting 2 U fans in it, and you're growing those fans at the back, and you're running adiabatic cooling in a large data center, those very small changes in the diameter of the fans make a huge difference to airflow and cooling through the product. And again, we have some 2U servers in our stand. You can go and have a look at those as well. So really, it's a holistic approach to it, including power. So the power architecture for a typical, for an open compute type product is an AC power supply coming in, a 277 volt AC coming into the data center and into the rack level, and then it's rectified at a rack level from 277 volt AC across to a 12 volt DC on a bus bar backplane. And what it means is we actually have virtually no cabling at the back, except for power cord inputs, and communication and networking cables are all in the front, making it a much easier product to work on. No need to really work in the hot aisle of the pods. So from Rittal, we've been involved 6 years now in the open compute community. We were developing the 1.0 specification, which was an original 12 volt spec with 3 power zones and 3 bus bars operating at about 12 kilowatts per rack. We started that, and we shipped many of these just to give some scale on this and what the deployments are looking like already for open compute. And we shipped 3,000 fully configured products between 2012 and 2015 roughly. And then we became lead developer on the V1.2 rack, which is the one you see on our stand. We started shipping that in 2016, and we've shipped maybe 15,000 of these complete configured solutions to date. So the scale is certainly out there. In 2016, Google announced that they were joining the open compute community, and they were looking at it jointly with Facebook to develop a 48 volt DC solution. And that's been developing over the last year and a half, and we've certainly shipped our first proof of concepts for the 48 volt DC solution late last year. Now, of interest to telcos in particular will be the 48 volt DC for obvious reasons, that legacy type power in the data centers is of course 48 volt DC. Obviously there's some advantages to it in terms of step downs and power efficiencies, and being able to utilize higher power racks with 48 volt DC with less losses. So I think as we go forward, we'll see a lot more 48 volt DC. The architecture isn't quite out there yet. We certainly have some on our stand from a rack point of view, but battery backups, power supplies, servers, in IT equipment is coming on board in the coming year, we hope. So as I already mentioned, one of the key features of this is the busbar system. And if you look at this in plan view, you can see the connection points on the busbar. On the left-hand side busbar, in fact, I'll start on the right with a rack. The busbar runs top to bottom in the center, and it allows a blind mate. So IT equipment, so a 12-volt busbar at the back will come off a rectifier in the middle, which will come in out on an AC power, rectify to 12-volt DC, and put it right down that 2 busbars you see at the back with 12-volt DC. And in plan view, you can see on the left and on the right there, the 2 plan views, the interconnection point between the servers, the IT equipment, and each of those busbars is exactly the same at the front or at the top as you're looking at it. At the back, you can see there's more orange area or copper. The only difference is on the left, we have a 15 kilowatt rated busbar, and on the right we have a 36 kilowatt busbar. Now in OCP you can put anything between 1 and 3 busbars from top to bottom depending on your application. So the application you see on the right is a single busbar, and that will operate at either 15 kilowatt or 36 kilowatt. You can actually put 3 in there, and there's set positions either side, and you'll see on the next slide that there's up to 3 busbars, which will potentially and theoretically triple that power if you need to. The most popular one and the most deployed one, in fact pretty much the only deployed one at the moment, is a 12-volt DC solution, which is what was started in 2012 and developed by the Facebook team and the community. And you can see on the right, the racks, we have different solutions, and you see these 2 on our stand. So you have 3 busbar solution, which is a standard OCP offering, and that allows for HPC or high performance computing type applications. So the one on the left of those 2 racks is approximately a 40 kilowatt power rack. It'll handle up to 40 kilowatts. The one on the right, however, is a split configuration, so we can split things where the bottom half has 3 busbars, allowing for a high performance computing configuration up to around 18 to 20 kilowatts, whereas at the top, maybe we only want 6 kilowatts, 7 kilowatts, and a mixture of 21-inch open compute compliant gear with 19-inch equipment such as switches, etc., and maybe some normal servers, some standard servers. So it allows a hybrid solution. The busbar interface, as you can see in plan view on the left, is different to the previous one. If I flick back, the previous one is a very thin busbar interface. The 12-volt are wide and apart. Each of those are made of some 50mm copper by 3mm. Again, it's OCP standard, and they're set distance apart, and they're offset by 3mm to ensure it's ground before the positive hits. On the racks, we can have different power zones, top to bottom, so you can split power zones or you can have a complete power zone. Maybe you want a single power zone all the way up because you don't want to split your power zone. Therefore, you can have something like anything from a 20 kilowatt or 20 kilowatt per zone, 40 kilowatt per rack, up to something like a 3.3 kilowatt, 13 kilowatt per rack. So there's various configurations out there. This is the more typical ones, but we've had some configurations where we will split the power zones into 3 ways and do some co-location work maybe. And we have some co-location examples again on our booth. So moving forward and combining Rittal smart solutions with some OCP solutions. These are products again you can see on our stand. We have various components. So things like split doors, split shelves, if you've got colo applications, maybe you want to do compartmentalized racks and solutions. Power shelves with optional batteries. So the power shelf, you'll see for these vary widely. On a Facebook type deployment, you would have a 3 OU power shelf, which runs with 2 OU of power shelf and 1 OU of battery backup. So it uses battery backup, so everything is at a rack level. There is, of course, the option to go to different power shelf solutions, where it's a smaller power shelf, but 15 kilowatt, but there is no battery backup. It uses a traditional UPS approach, sorry. We've also got LCP, so Rittal's a liquid cooling package, chilled water, our next generation, is set on our stand. We have inline cooling available for this. So I was talking earlier about power density increasing, particularly as we go to artificial intelligence, as we go to virtual reality, etc. The need for open compute and the deployments is in, particularly in things like social media, guess Facebook's an obvious one of uploading videos, etc. YouTube being another one. The power consumption is going to grow for this type of application as we go forward. So the need for a solution-driven cooling system is critical. And we also have CMC monitoring as a part of the overall solution for this. From a benefit point of view, everything from a single rack up to a container of full data centers. Typically these are deployed, and we've seen them deployed at hyperscale level and rolled out in the thousands, down to a more enterprise level of co-location type sizes of tens into a couple of hundred, into a few at a time. And there's certainly worth, if you get a chance, is to go onto the opencompute.org website, having a look at some of the use applications on there and the solutions that are out there from various deployments around the world. So in terms of the OCP container, as a business case, so Rittal are doing this at the moment. We're looking at this, and we've done with 14 rack application with 5 LCP, 55 kilowatts on board with power shelves and optional batteries, and some IC components inside. We're estimating a capex and operational cost calculation and ROI of around about 2.5 years approximately. This varies dramatically. I think generally OCP hardware availability in Europe is not as good as in the US. In the US it's much more available. In Europe the awareness of OCP is not as much as it is in the US, but it's growing all the time. And in fact our first distributor is just sat here of WeWin equipment from Circle B in the Netherlands, Menno. So as we get more channels on board through Europe, and people who distribute hardware, then we can provide complete solutions for power shelves, cooling, hardware, IT equipment, and so on. So what drives OCP is worth promoting the summit that's going to happen in October of this year. Every year there's a summit in the US, over in normally in the sort of Silicon Valley area in California, and that's where it started off maybe 7 or 8 years ago with a couple of hundred people, whereas now there's something between 5,000 and 8,000 people visit the summit every year. This is the first regional summit that's going to happen over at Amsterdam in around about 1st and 2nd of October. I think there's 2,500 registered to go there at the moment. We certainly will be as a GOAT sponsor of OCP. We will be showing our solutions and our products there. It's well worth coming along. It's normally a mixture of keynote speakers from a lot of the US IT companies. There's certainly some workshops there. We have very detailed engineering discussions, and you get the opportunity to feed into the community. I've been doing it personally for 6 years now. It's a great experience to do it, and it's great for solution providers like Rittal. So I guess with that in mind, I'm going to wrap up now. If there's any questions anyone would have on OCP, then please fire away.
Are there any questions?
No?
No questions?
Okay, thank you very much.
Thanks for being here.